Okay, hi everyone. All right, so I'm Bryan English. You can find me online everywhere at that username, GitHub, Twitter, whatever. Everywhere I use that username. I work at DeNA, which is a pretty big Japanese mobile gaming company. We got offices here in San Francisco, and all of our game servers use Node.js, so that's why I'm here today. And of course, we're hiring like crazy, so if any of this stuff is interesting to you, come and talk to me afterwards. So I'm here today to talk about converting existing APIs over to using promises, both internally and externally. And so what I mean by that is the innards of all your methods are using promises all the way down the chain. So we've been going through this process at DeNA for the past few months. And so yeah, we'd like to share it. So our team builds a set of common game server code so that other game teams can use it. And so we have sort of an RAD tool for building game servers. So yeah, originally all of that code was just callbacks all the way, normal Node stuff. But we started taking a look at promises and we realized this is pretty cool stuff. It'd be great to have our APIs looking this way. So we started experimenting and kind of fell in love with it, and so here we are today. So yeah, one of the bigger concerns was backward compatibility. So we have lots of game teams dependent on this code, and so we wanted to make sure that they didn't have to move all of their code over if they wanted to use any of the new features of our API or anything like that. So backward compatibility was a pretty big concern, so that's one thing I definitely want to talk about today. Also, I realize I probably have the only talk here at Forward.js that has backward in the title. So I think that's pretty reasonable, though, because backward compatibility is pretty much the only way of moving forward if you want to be responsible, I think. So also, any of the stuff I'm going to show you today, I've only really done from a Node.js perspective. I haven't done any front-end work in years. So if you're a front-end JavaScript developer, use Browserify. All right. So probably some of you, maybe most of you, already know what promises are, but best to go through a quick intro, I think. So let's go through a couple of the basics. So here's the definition, both from the Promises A+ spec and from the ES6 draft. So Promises A+ says a promise represents the eventual result of an asynchronous operation. All right, that's not very clear. I think the ES6 draft says it a little better. So that's a promise is an object that is used as a placeholder for the eventual results of a deferred and possibly asynchronous computation. So I think that definition is a little bit better because it describes it as an object and not just as a placeholder and not just something that represents something, because it is definitely an object. Okay, so the most important thing about promises is that they're basically little state machines. You've got 3 states they can be in: pending, fulfilled, and rejected. They can only be in one of these states at a given time. And they can only go from pending to fulfilled or pending to rejected, and not from fulfilled to rejected or the other way around. So basically, once it's hit a fulfilled or rejected state, it's done. That's the end of the state machine. So the fulfilled and rejected states also have values associated with them. So these values basically represent the result of your computation, right? So in the fulfilled case, that's just basically the result of what your function was doing, right? So if you're thinking of this from a node perspective, it might be equivalent to the second parameter in your callback. Whereas in the rejected case, that's your rejection reason is what it's called in the spec, it's the value that's associated with that state. And the rejection reason hopefully is an error class object, like an instance of the error class in JavaScript. Okay, so also I want to point out that some frameworks, some standards, some specs will refer to fulfilled as resolved. I'm going to use fulfilled for this presentation. If you prefer resolved, but just substitute in your mind, I guess. All right, so I guess the next most important thing about promises is that they have a function on them called then. So that's where a lot of the magic happens, and that's what makes them really useful to us for dealing with asynchronous code. So here's an example. I've got this function getResultPromise, which returns a promise. And so because of that, we've got a function then on it. All right, so then takes in 2 callbacks. The first one is one that will take in your resultant value, like again, if we're talking about the first value, or sorry, the second value in a node callback. And the second function would be like the first parameter, so more of your error object. So only one of these will ever get called, because again, we're dealing with the state machine. It's only going to be either in the fulfilled or the rejected state. Okay, so there's this syntax, and then we've got this syntax here, right? So we've got then and catch. So the important thing here is that both of the callbacks in then are optional. So just doing then like this without a second function being passed into it is totally fine. So that means we're only dealing with the success case. So in the error case, it'll get caught by this catch down here. So catch is equivalent to running then with no first parameter and only the second parameter. So yeah. So the great thing about them is that we can start chaining things together like this, right? So with then you can do all kinds of stuff in there. It doesn't have to be just just reading the result. You can be returning something, right? So here I'm reading the result value, and then I'm adding 1 to it, and then just passing it along. And the way you pass it along inside a then handler is by returning. You could also throw an error in there, and that would make the function that's returned by then rejecting promise. Sorry, it would make the promise a rejecting promise. There we go. So yeah, that's great. So then returns promises. That's a very important thing right there. So also you can, instead of returning value, you can also return a promise, which will basically make the promise returned by then fulfill with the same value as that promise there, the one that's returned by get another result promise. Okay. So that was my quick intro to promises. Hopefully you still think promises are cool. So if you're like me and like the company I work for, you have a mountain of really old code. And, it's not necessarily straightforward to convert, all that mountain of code into stuff that uses promises all over the place. So, let's start from the bottom, right? Sometime, somewhere, you're going to have to use a function that returns a promise. So we can go forward with the examples that you saw. So unfortunately, for us, from the node perspective, none of the node built-ins return promises. Instead, they're all callback style. And there are some modules on NPM that will return promises, but not very many, and the standard is still callbacks pretty much everywhere. So, what do you do, right? We could start wrapping up all of these APIs with the promise constructor, but I haven't even talked about the promise constructor yet because most of the time you don't need it. And you don't need it because of some cool libraries like Bluebird. So Bluebird is a pretty awesome implementation of promises written by this guy named Pekka Antonov. Now Pekka is very, very big on performance, so Bluebird turns out to perform very well compared to some other libraries. And it also provides a bunch of nice little helper functions that'll help you get going. So, promises are in ES6 draft, right? So some environments will support them natively. You can get them in Chrome, but they're like slightly off spec. I don't remember the exact details. But libraries like Bluebird and Q are going to be helpful no matter what because they're always going to provide extra helper stuff on top of the spec. So yeah, we use Bluebird at DeNA, and we're pretty happy with it. And it's pretty easy to use. Like everything in Node, you're going to npm install it and just require it. So basically, we're going to require Bluebird and then use it as our promise implementation just like that. We're not going to be like bar Bluebird equals Bluebird or something like that. It just makes things a whole lot easier. So let's see that in action. This is one of the most important features of Bluebird is the function Promisify, which you'll see on the third line there. Basically, it'll take any function that accepts a callback as its last parameter and make a promise version of it. So here I'm using read file from Node's FS built-in library, and just I'm running read file, reading a file called stuff.json, and passing it into JSON parse. So again, I can use JSON parse here just like any other function as my then handler function, in this case the fulfillment handler function. And the reason I can do that is because JSON.parse will take in a great big object, in this case a string, and then return one thing as well. So it takes in one thing, returns one thing, everything's happy, it's great. So it can be used quite easily as something in then. So that's one interesting thing, is that it doesn't always have to be asynchronous code that ends up in your fulfillment handlers or your error handlers. Okay. Let's see. Cool. So yeah, this is Promisify All. That's another useful thing on Bluebird. Promisify All is great because it'll take any object. In this case, I'm just taking the FS library in and of itself. It'll find all the functions on it and basically create an asynchronous version of them. And by asynchronous, what I really mean here is something that returns promises. So you might see that in some of my further slides. I'm using async as a suffix on something that would already exist. And the idea here is I'm just taking a function that would already call a callback that's passed in as the last parameter, and then just operate that way as if it's in promise land. So that's pretty cool. Okay. Cool. So also it's important to note that functions like Promisify and Promisify All, as they are in Bluebird and probably some other libraries, are a little bit performance intensive. So if you're doing this in Node, probably you don't want to do this like in a request response cycle. You probably want to do this all at startup during your initialization time if you can. Obviously there's some cases you can't, and just deal with it. All right, so that's all cool, but as the title of this talk and kind of a point I've been harping on is backward compatibility, right? So, I mean, when you're adapting your code to use promises in this way, you're probably going to want to be backward compatible for some amount of time, maybe not forever, depending on how you do your releases. Maybe you're using Semver or something like that, and you want to push a new major release later on. But for a certain amount of time, you're going to want to be backward compatible in order to make your API consumers happy. So Bluebird makes this very easy. So here's an example. I've got some function getUser. It's getting something from a DB, then getting something else from another DB. So it's got to do a couple of things that are asynchronous. And this, let's just say this is like an existing function in your internal API, right? So, I mean, now I've gone and permissified it, right? So, I mean, get from DB and get from other DB async. So these are functions that I'm assuming we've run Promisify All on the library that provides them, right? So now I've got these functions that return promises here. And that's great. Everything's great. I'm returning promises. Everything's nice and cool. So backward compatibility needs to happen. And notify is the function that'll do that for you. So Bluebird provides this function called notify. I'm sure some other libraries do, but we've spent so much time in Bluebird that I'll keep referencing Bluebird. So notify will basically take in your callback and call it normally, like you would expect in Node land, where the first parameter is any errors that happen. So basically, it'll be the result of your rejection handler, right? And then the second parameter will be whatever would be passed into your fulfillment handler, right? So the other thing is that if a callback is not passed to this function, it's assumed that it is intent on returning that the caller is intent on getting a promise out of it. So if you just call it with getUser and some argument, it would actually just go ahead and return a promise. So that's very cool. It does everything for us. We're nice and backward compatible. So yeah, those are some pretty simple examples. So we have all kinds of code that does some slightly crazier things. It's not always just a matter of returning a promise or calling a callback or both, right? There's weirder things that happen. So say, for example, you have some kind of hook function that you call inside your function. And what I mean by that is something that will be running somewhere deep inside your function, maybe a couple of callbacks in, that kind of thing. And it's just allowing the caller of your API to do some other extra stuff inside the course of calling that function. So, I mean, we could just go ahead and assume that it returns a promise, right? It would be nice, and then we could just convert everything as we were converting before. Now, that's all fine until we try and be backward compatible. All right, so if we're doing that, then we have to deal with the case where this hook function can either be returning a promise or calling a callback. We don't know which, right? So, I mean, you could try using, the Promisify function that's in Bluebird, But I mean, this isn't going to work because it's already making the assumption of calling a callback, right? So it's not quite there, but we're really close, right? So this is sort of a simplified version of the Promisify function that's in Bluebird. And it turns out that this is almost all that we need in order to get this done, right? So let's look at what it does. One thing I want to point out here is I'm actually using the promise constructor, and I didn't introduce it before because most of the time you don't need it. But in this case you do, so just a quick overview. When you use the promise constructor, so you're going new promise, and you're passing in a function that takes in a fulfill and a reject function. So basically you can do all the asynchronous stuff you want inside this constructor, and then just make sure that you call your fulfill and reject functions. So the way I'm using that here is I'm basically taking the function call as it was, right, with the arguments object there, and then I'm pushing on this callback function, and then we're just going to go ahead and call that function, right? So the callback function I'm putting on there, it takes an error and a result, and it'll call either the reject or the fulfill function based on the value, or sorry, based on the results that we get back. So that's great. I mean, that's pretty much all there is to Promisify. But again, what we really want to deal with is also the case where the function does return a promise. And so we don't have to deal with all of this callback stuff, right? So that turns out to be relatively simple. All we really need to do is take the value that's returned by the function that we're promisifying and then check if it basically quacks like a promise. Right? So promise is all of it .then, so we can check for that. There's a few other things we can do, but this is just a simple example. So if it does look like a promise, we can just go ahead and fulfill that, and then the resulting promise will take on that fulfillment value, the fulfillment value of P in this case. Okay, so one interesting thing that we ran into with this approach is that when we had built some APIs that have that notify at the end, right, so they could return a promise or they can call a callback depending on how you call it, and you pass that function into something like this, well then what happens, right? Because it's intent on doing both and this is intent on doing both. So the result of that actually is pretty simple when you think about it. So your function is going to return a promise always, right? So even when you do notify and you call it with a callback, it'll still return a promise. So that's what'll win basically, right? So that one will be returned because when you call your function, the callback there that has reject and fulfill in it will only be called at some later time. You know, if I'm thinking in node language, it'll be in some next libuv tick or something. Whereas the promise is returned right away. So right away we can go ahead and fulfill it. So the first thing that ends up calling fulfill or reject will win, right? Because again, it's a state machine. You can't go from one state to another after you've gone from pending, right? So that ends up working. Yeah, I also want to point out that this is a rather optimistic version of this function. Like I said, like just checking if there's something on it called .then is not sufficient. But yeah, this is good enough for example. All right, so here's our original example. I can use that safely promisify function that I built over here, right? And just call that on that hook function as if I was doing promisify before, right? So it's exactly the same. We're just going to wrap it up with safely promisify, then call it, and that will guarantee us a promise. So that's great. Now we're backward compatible both with either taking a callback or returning a promise, and with the hook function either taking a callback or returning a promise. So that's great. So now we have some backward compatibility. That's great. So yeah, before we moved over to doing promises everywhere, most of our code took advantage of async.js. I think most people who do all kinds of Node or other code that involves a hell of a lot of callbacks will definitely have some experience with async.js or similar async helper libraries. So it turns out you can do basically all these things that you would do with async.js with promises just the same. So let's go over a few of those things. So here's one. Parallel is a pretty common one. Basically, you're firing off two asynchronous actions and waiting until both of them are done. So here I'm assuming that do something 1 and 2 are functions that take in callbacks and do something asynchronously and independently. So there's no state shared between them or anything like that. So also, I mean, when you're using async parallel and these functions don't require any context, you can just go ahead and pass these things in, right? But instead, probably you're going to end up with some functions that have some context, so you have to call them on the object itself or do some bind or something like that. So here I've just wrapped them up in functions, make it easy. All right, so the parallel equivalent or rough equivalent with promises would be all. Now, all is provided by pretty much every promise library. I'm fairly certain that it's in the ES6 draft, so you should have it everywhere you have promises. So here I'm assuming that I've wrapped this library called obj with Promisify All. So now I've got these async versions that return promises, which is great. So the interesting thing here is that I'm just calling these functions in the same scope that I was in before, right? So I'm just taking these and I'm returning promises, and the promises themselves are being what's passed into promise.all and not functions that return promises. So that's a key difference, and I think it makes things easier. Pardon me. So in promise.all, if any of these functions reject rather than fulfill, then the first one that rejects, that'll be the rejection reason that is assumed for the entire object that's returned by promise.all. But if in the case of success where all of these promises do in fact fulfill, then all those fulfillment values will be an array, which will be the fulfillment value for the whole promise that's returned by promise.all. So that's cool. Let's look at waterfall. Waterfall is a pretty big one. This one was all over our code before we started converting over to promises. So basically in waterfall, you're doing some asynchronous action and then doing another one right after that. This is dependent on the value from the first, or maybe it isn't, doesn't really matter. Also async.series would be the same thing, except we wouldn't be passing this some value along. All right, so again, the same assumptions about a library that we're using here, obj. All right, so I mean, with promises, this is dead easy, right? The whole structure of then is basically there to help you do this sort of thing, right? So we're taking the value that's that's fulfilled from do something one async, which again, this is a Promisify All has been applied to this object library, right? And we're getting some value out of it, and then we can just go ahead and pass that to the second function and return that, and the whole thing returned by this will assume that fulfilled value. So that's dead easy, but sometimes you don't have a set of functions that you control, right? Or maybe you do control them at just some other place. The idea is you end up with a dynamic set of functions. One good example of something that would do this is if you use Express's middleware chain, or connects middleware chain, right? So a whole bunch of functions get added and then executed like within a nice asynchronous chain, right? So, I mean, you can use async series or async waterfall to do that in, callback land. So with promises, it's not quite as simple, but it's pretty close, right? All we really have to do is use something like reduce. And, I mean, reduce you have in pretty much any reasonable newer JavaScript environment on arrays, right? So you can just call that and just use that to tie all the then blocks together. All right, so I'm actually starting the chain for reduce with promise.resolve. So what promise.resolve does is it gives you a promise that is basically already in a fulfilled state. So you can go ahead and just use that to start off your chain. So the result will end up effectively doing the same thing as this, right? Pardon me. So we take our array of functions, we just iterate over it, and we're calling then inside each one. Or sorry, we're calling then around each one. So yeah, that's pretty much all there is for series. Another big one that we tend to use all over the place is whilst. So here we're basically talking about we're passing in two functions and then a callback. Sorry, that's three functions, I guess. So the first one will be your condition, right? So this will be executed each time it loops, and then if it returns true, then it'll go into the next function, execute that, do something asynchronous, and then call the callback that's passed in. All right, so that's cool, but we definitely want a promise version of this. So you can construct a method like this to help you out with general cases. Right, so here again, I've got a condition and an action. And an action is the function we're going to run at each loop iteration if condition is true. Right, so here I've gone and basically done a recursive call. So in the waterfall or series example, I mean, we were able to make a nice linear tree of thens. We can't really do that in this case because at each step we have to check whether the condition is still true. So instead, it ends up looking rather recursive. So yeah, that's all there really is to doing effectively a while loop in Promised Land. All right, so I mean, here it is in action. It looks exactly the same as like our original case, except with no callbacks, right? So this will return a promise, and basically this should iterate 5 times, and everything should be great. So we found ourselves doing a lot of this sort of thing, making little helper functions like whilst and doing something around reduce and that sort of thing. So we put together a library of them. We call it Thrush because it's I mean, Bluebird is a member of the Thrush family, so we figured it would be some pretty interesting naming. So some of the main, you can get it on our GitHub page and npm install it and all that good stuff. And you can use it pretty much the same way you would use Bluebird because basically we extend Bluebird with these extra functions. So anything that's available on Bluebird will also be available in Thrush. So we've added the safely permissify function that I showed you before. That's the one where it'll either return a promise it'll take a function that either calls a callback or returns a promise and makes sure that for sure it will return a promise. We have a function called series, which will do a lot of the stuff that you saw that would be similar to async waterfall or async series or async for each. There's a whole bunch of methods to kind of wrap them all up into one. And also the whilst function that I just showed you. Okay, so yeah, there's also a few other little functions in there that basically we built this to help us convert from code that was very heavy on using async.js over to using, well, Bluebird and promises. All right, so there's depending on how you design your API, there might be a few other things you may have to deal with. For us, a lot of it came from the fact that you can only have one fulfillment value and one rejection reason, and not both, right? So if you have some function that you're calling your callback with null in the first parameter because it's a success case, and then 2 parameters after that instead of just the 1. Well, then you might have some interesting things happen. So like here's an example of that, right? I'm doing get things, it's doing something 1, doing something 2, all nicely in series, callback style, making sure to deal with my errors, right? Pardon me. And then we're calling the callback with 2 results. And this kind of thing was pretty much littered all over Codebase, still kind of is. But this isn't that big of a deal, right? You'd think it would be because you're only supposed to have 1 fulfillment value. But it's not a big deal. So one thing we could do is we could call Promisify on this whole thing. Now Bluebird's version of Promisify will actually go ahead and take those 2 parameters and wrap those up as an array. And that array will end up being your fulfillment value, which is great. So what we want to do when we convert our APIs over is emulate that behavior so that we can use Bluebird and other libraries that behave just like it. So we would do something like this, right? So notice I've taken the first result and brought it into a higher scope. That's because in the previous example, right, we still have access to result 1 in the scope of the callback of do something 2. But that's not really the case here because everything's all nice and linear. Right, so it brought result 1 into a higher scope, and now I'm able to return an array with result 1 and result 2 at the end of my promise chain. So, I mean, we could also have done something like pass it along as part of the fulfillment value, but, this is pretty easy to do. All right, so the result of this, again, we have an array of the results, right? So I can call that function, I've got my results object, and there we go, it's an array with 2 objects in it. That's great. So Bluebird will also provide you a function called spread. And this is great because you can take an array that is your fulfillment value and then just treat each element of that array as if it's a parameter to your function that is your fulfillment callback, So that's great. Other than that, spread operates almost exactly the same way as then. Okay, so we also want to maintain backward compatibility, right? So obviously we're going to do notify, but now I've passed in a second parameter to notify, and that's an options object. This is actually a very new feature in Bluebird, so if you haven't used Bluebird in a while or something like that, then you may not be familiar. But basically you can pass in an options object to notify. In this case, I'm using the option spread as true. And what that'll do is it'll make sure that any array that's the fulfillment value of the promise that you're calling notify on will be spread across the callback. So it'll be calling it back with, if there's no error, you'll get null, and then the first element in the array, and then the second, and so on. So that's great. It's nice and backward compatible. It's operating exactly the same as the function we had before, except now it's returning a promise that does effectively the same thing. So that's all good. So if you write a lot of Node.js code or any other code that does a lot of asynchronous stuff, you know that your stack traces are not as great as they could be, right? In Node, you're going to end up with things that stop at like, next tick callback, something like that. And it's not great, right? So like here's an example of a function that does something asynchronous, does a couple of things in some thens. I just haven't bothered to put them in, but anyway, somewhere along the line, we've got a then that throws an error, so that'll create a rejecting promise. And then we've got a catch rejection handler there that'll just go ahead and log the stack. So, I mean, when you run this, assuming that there's actually something in those then blocks, you're going to end up with a stack trace that looks something like this. So in the interest of making this fit on the slide, I replaced the big long references to like locations in Bluebird with in Bluebird. Bluebird is pretty crazy in terms of how many stack frames it adds. So you end up with some very ugly stack traces this way. And again, it stops before you even see like where this do something async was called, right? You don't see that at all. All you see is here test.js 5.9, that's where the error was actually thrown. So it's not really enough information. So you can actually tweak Bluebird a little bit, and the result of this is you get from previous events. So Bluebird will actually tie asynchronous things together and remove itself from your stack traces so you get some nice output. So here it's showing me test.js 1 and test.js 5 in here. So those are two sites that are relevant to the code here, right? So line 1 and line 5 are where things have happened. So that's great. It actually has some useful information now. So you can activate this in Node by setting an environment variable, bluebird_debug equals 1. Or if you're in a browser or just you don't want to mess around with environment variables, you can just call promise.long stack traces. And that will do the same thing for you, and you can get all that stack trace data. Okay, so when we did this, when we made this conversion, obviously we had to take testing into account. Now we use Mocha, like I'm sure a lot of you do, and what we found the easiest thing to do is double our tests. So for everything that was testing some code that was asynchronous, we would have two versions of our test code. We'd have one that was all callback style and one that was all promise style. And the advantage of that is that now we're absolutely sure that both sets of APIs work and that we're still backward compatible. So that's definitely something to do. And the other thing is, if you have any plans on removing the callback style of your API, we may or may not, we don't know. It may not be a good idea, who knows. But if you do have such a plan, then it's very easy to just go ahead and delete that whole set of tests, just by keeping them nice and separate, but making sure there's two of them. But there are some weird quirks in Mocha in particular. So if you're using Mocha with a version less than 1.18.0, you're not going to be able to do the cool things you can do in later versions. So it would be great to just pass it or just return a promise, and then if it fulfills correctly, then it's a pass, and then if it rejects, then it's a failure. We can't really do that in old versions of Mocha, so you're going to have to treat it like any other asynchronous code, and get this function done, and then call it with notify, right? So that'll make it behave just the same as any other callback style code would. But luckily, in versions of Mocha greater than 1.18.0, or greater than or equal to, you can just return a promise. And like I said, if you just return a promise that fulfills, it'll be treated as a success case, And if it rejects, it'll be a failure case. So yeah, we're doing this now. We're using Mocha, I think, what is it, 1.20.0. And so we're doing this pretty much everywhere now. So I mean, there's obviously the question of whether this is worth it. I mean, we did spend a lot of time going through this conversion process. And yeah, it was definitely a lot of work. It took us at least, it's like 3 to 4 months since we started taking a look at this. But I think the best way we can measure this kind of success of this kind of project is by talking to the people who are consuming our API, right, and seeing what they think. And so I did have a few conversations with the game teams that are using our code, and they seem pretty happy with Promises. They definitely feel like they're using a lot less boilerplate code, and a lot of them didn't like async.js. Some of them did, but most of them didn't. And they're also pretty happy with the benchmarks they see from Bluebird. I mean, benchmarks can be a little misleading, but the benchmarks for Bluebird are pretty good. And they're also definitely happy with backward compatibility. So we didn't force anybody to upgrade any of their code, or side grade, whichever way you want to look at it, convert. So they were pretty happy at doing that at their own pace. So that was a good thing. Yeah, that's all I got. Hope you enjoyed it. Thank you. So you can actually grab all these slides on GitHub. It's just my username, bengal/forwardjs-promise-talk. You can also npm install it. So this presentation's all in a terminal. All right, questions? Yo. Okay, so the question is, would it be a rational approach to have a set of code that is all normal and callback style and then call Promisify All on it and then provide it that way? Yeah, it wouldn't be that terrible. Right, so, sorry, just to repeat, he's asking about performance now. So, yeah, there's definitely going to be a performance difference. I mean, we're taking things that are not native to the language, not native to the framework, or to the environment, and we're adding all kinds, like you saw all the stack frames that were added, right? Like, it's not going to necessarily be, it might not be faster. It really depends on how your code is structured, right? And to be honest, when it comes to performance, you're probably going to run into other performance bottlenecks anyway, right? But for our sake, we just decided to convert everything internally inside all of our APIs just because we find them a joy to work with. No, so our testing stack is basically just Mocha and Sign-On. So, I mean, with that stuff, I mean, it's fairly easy to make stuff work. You don't need any extra helpers with that. I'll definitely take a look at Chai's promise, though. Yeah. So the question is, like the safely permissify function I provide here is fairly similar to what's in Bluebird, and you know, why doesn't Bluebird provide a similar thing? You'll have to ask Petka. No, so I had a few conversations with him on IRC, and basically it came down to it's simple enough to do on your own. There's no real reason, but he sees no real reason, as far as I can tell, from my conversations with him. But for us, it's very useful, so we're perfectly happy to put it in a separate library and use it that way. Okay, so the font. Let's just go ahead and grab it. Oh, sorry, it's on my other screen here. Perfect DOS VGA 437. Yep.
Very flexible because I can just add any task to control it.
Okay, that was a lot of stuff. I don't know if I can repeat all of that, but I think a lot.
Is it similar paradigm, but the wrapper?
Yeah. So for those who didn't hear, he was discussing some stuff that he was doing with JavaFX, which ends up actually, from what it sounds like, it sounds like it's doing a lot of, or what you were doing. I'm not sure if it was what you were doing or what JavaFX was doing.
What JavaFX does using the Win.js library.
Okay, cool. So just using similar stuff to what JavaFX was doing. From what it sounds like, you're doing a lot of the same stuff that happens internally in Bluebird. So, yeah.
I've not seen the internals. I every new Bluebird existed before today.
Well, I highly recommend taking a look at Bluebird and Thrush. So, yeah. Sorry, one more time. There's a lot of doors opening. Okay, cool. All right, cool. Well, thanks, guys.